Hello everyone, welcome to Enception EV. Before I start talking about today's topic, let me tell you that surrounding me there are a lot of workshops that is working on right now. That's why there are a lot of background noise. So I hope you can hear me well and can understand me. So let's begin. So today's topic is all about the new MOSFET switch that I built. Okay. So this is the new PCB design, and if I show you the last one, this is the last PCB that I tested with the 120 millimeter fans. You can remember that. So if you check these two side by side, you see there are a lot of updates that I made in comparison to the size and the tracks. So uh, in the new PCB, a lot of changes has been made. Like the tracks, the traces are wider. Then there are less tracks than the previous one in compared to this one. So what I did in here, let me tell you about it. So uh, this switch is about to use. Sorry. Okay, again. So this switch is about to use a 87-volt charger module that will split uh, into to charge two batteries. So here, this is the 87-volt charging module, and this will charge 272 volts batteries, like you see in here. And this is the new test jig that I will show you in a few minutes. And this charging module capable of delivering 87 volts, 12 amp hour continuous current at a time. So that's why I need these tracks rigid enough for this copper clad that I'm using here, so that it can stand the heat will generate by this charger. That's why I need to widen the tracks, and because of the widened track, I need to make the whole PCB bigger, about 40% bigger than the last one. Okay, so that's one change that I made, the widen uh, tracks. And there are two important updates. Like the old MOSFET that I used was this one. I don't know if my camera can take the focus on it. Okay, so let me tell you. This MOSFET was IRF-B4110 MOSFET. It's a simple regular MOSFET. This MOSFET I used in the previous switch in here. You see with the heatsink. This is a regular MOSFET, and now I'm talking a lot of technical things that I also don't know, but that's what I learned throughout this journey. So I'm sharing you about that. If you ask me why is that, I can answer. So I'm sharing what I learned actually. So this MOSFET needs 10 volt of power to fully open, and I am powering this MOSFET with a Arduino Uno. That's why the Arduino Uno maximum output is 5 volt. So that's why when the Arduino Uno sends command to open this or turn on this MOSFET, it will not fully open. And if I use this MOSFET, then the full 87 volt will not pass through. with just 5 volt of power from this Arduino. That's why I need to change the MOSFET to this one. This is a logic MOSFET. Its number is IRA540N. So this is a logic MOSFET and it needs just less than 5 volts to fully turn on. And this is suitable for powering by the Arduino. That's why I used this one in the new switch. I will share you the assembled switch in a moment. So that's the MOSFET that I use, and in the previous version of the switch, I used this diode, and this diode can only handle about 40 volts or something. It it is not enough power to handle the total 87 volts or the 72 volts that the recurring current to not go to the MOSFET but pass through this completed circle. So that's why I needed to change the MOSFET, the diode as well. So this time I used this diode, and this number is actually 20150 MBR, I guess. MBR 20150. So this can handle 12 amps of power and 150 volts. So that's why it's the suitable option for this whole setup. So these two components I changed actually. So as per the components, yes, the MOSFET and diode has been changed, and I changed the track size, the overall size of the switch. So these are the updates that I made in this new design. So this PCB is completed, and this is the old jig that I built for testing this switch, and this is the old switch. And now I'm sharing you the new jig that I built. This is the new switch. You see, two heat sinks for one for the MOSFET and one for the diode. Okay, so here you see this one is little angled because there is not enough space in these two components to put the heatsink upward, because the heatsink is bigger and I didn't consider it when I designed it. So that's why. But it's okay. It's okay for the testing purpose, because heatsink I can change the heatsink to new design or something simpler one. So it's not a big deal. And if you check this old PCB that I used, small terminals which are okay and work well, but in this time I used high gauge wires. You see, these are high gauge wires. I guess it called 40 gauge wire in my local shop, and I used this sort of terminals to connect with the charger and the batteries. And here is one simple cable that I cut into half by mistake for the to use it on the Arduino. And here is the whole jig. This is the Arduino. There is a power on off switch for safety, or it just makes it a whole setup that will be assembled on the actual charger. That's why I put this switch in here. And then there is the Arduino, there is the switch. This is the charger for the 72 volt battery, and this is the charger to charge the 12 volt battery. So at first I will start with the smaller one. So I already assembled the big charger in here, But if I remove it, there will be four more legs or mounting holes to mount this one. Okay, and also in here you see these two heat sinks. I like this design actually. They are simple, small, and good enough. So I may change my heat sinks and look for this type of heat sinks. Now the jig is complete. New jig is completed. Everything wired up, and if you see the battery, these batteries are ready for testing. The one hurdle that I am having at this moment to connect this smart BMS with the Arduino so that they can communicate, and the Arduino can evaluate if this battery needs to charge or not. So if this battery's charging state is low, then this Arduino will send the command to the MOSFET to turn on, and then the charger will keep charging it. And the problem is this smart. I use JKBMS. JKBMS. So these are good BMS and they are really well built. But the problem is they have CAN port and RS485 port, which connector I don't have. And I was misled by some Google images that the GPS port can actually work as a RS485 port, but when I checked the actual manual of this BMS, then I found out that these are not true, which I cannot use. And even that port is so small that I had to go to Dhaka to find these small connectors. And now I I actually managed to resource it, but and I found out that I cannot use them. They are useless. They are just for GPS, which at this moment is not my concern. But I can use that in future. So my next plan is to open this shield here and get access to the actual CAN port in the PCB and then solder the small wires to it. I know it's risky and I'm not a professional, but still I had to do it because I have no other way to connect the BMS to the Arduino. That's why I need to take that risk. So and I'm using the smaller one, so the cheaper one. If anything goes wrong, then it will goes on to this, not the bigger ones. Okay, so that's my plan. Today I will try to connect the BMS to the Arduino. Once they can communicate each other, then the whole system is ready for test. And once I finish the testing, I'm good to go to build the actual charger. So I'm in a good situation right now, and I'm hopeful that everything will be okay because I know what I'm doing and I did all my groundwork. So I am sure that I can do it. I can handle it. Okay. So that's my plan. So once I finish the 12-volt battery, I charge it. I connect it with the Arduino. Then I connect the switch to the charger and to charge the battery, and the Arduino will send the commands. Once those are all communicating well, I will start. I will test the bigger one. Then these two tests are complete. Then I will start building the actual uh, enclosure for this one. And as you see, behind me, those two are the bigger enclosure for the big batteries. So everything is going smooth and as planned. So I'm hoping that I can finish the test in today or tomorrow. Then I will share you the test video as well. So uh, pray for me and stay tuned to see the test videos, and I will start pumping new and new updates to my YouTube channel, to my LinkedIn, and to my Facebook. And there is a new announcement I want to make. So you see, this PCB, I will help anyone, anyone who has this DIY small CNC machines for building these PCBs. I learned it to the hard way, and if anyone interested to know how I learned it and how I did manage to do it, let me know in the comments. I will create a tutorial video so that you don't need to learn how I did it, because I tested a lot, a lot. I tested a lot of ways and I wasted a lot of PCBs. Then I learned it. I broke about right now about 20 bits. Then I managed to learn it. So I will help you. If anyone interested to know how I did it, let me know in the comments. I will create a tutorial video for you. And to my Bangladeshi viewers, if you guys are also interested, let me know. I will create a separate tutorial video in Bangla so that you can understand me well. So that's all for today. And once I finish uploading this video, I will jump into my actual work. Hope for the best and stay tuned. Subscribe my channel, follow my Facebook page, and follow me in the LinkedIn as well, because there's three platforms I usually use to share my contents with my audience. So have a great day. Peace.